very much. Good morning, delegates from Russia and from Myanmar, and all participants from Thailand, especially from LDD. Yes, my name is Romhan Munchan. I'm a soil surveyor for the senior level. So today I'm very pleased to present you about the digital soil mapping. Maybe some of you already know it already, because it's kind of new approach, which is going to be released. It's already released, of course, but it's going to be replaced, not all, in a part of the conventional soil mapping in the world. Especially that if you have seen for the soil survey manual, which is allowed by USDA, half of that book considering to the digital soil mapping. So Russia yourself also has that kind of method being applied. Yeah. Okay. Let's talk about soil. Why soil is relating with digital soil mapping, and how the soil is important. I used to visit Russia, Moscow 2 years ago. It was the digital soil mapping for consortiums. They have global soil map consortium. I went there to present about how to modernize the digital soil mapping in developing countries, especially in Thailand. So, if any country has soils, yes, we have to deal with the soil mapping and giving the information. And then recently we are talking about digital soil mapping in the world. Of course, the very advanced in very far countries, they are very far more advanced and more high technology than us, like America, Canada, Australia, and they are more ahead than us. But so today, about the digital soil mapping, I'm going to consider about in developing country or undeveloped country, how to apply it, how to modernize the conventional soil survey towards to the digital soil map. So this is just, today is not like the presentation, so giving you a teachings, no, but it's about the sharing, the experience, what Thailand's have been trying and have been testing. So I would like to have a briefings about digital soil mappings based on remote census data. But today, briefly and focusing is talking about the airborne camera imagery. And one technique that I would like to share with you is about the first logic method, which is going to be replaced for the methods of mapping. Sorry. Okay, I have 45 minutes, but I have more like 18 slides. The slide presentations is more than, but I will briefly talk about this, but I give the presentations to all of you here. And then any questions can be in the cluster here, or can be later by my email. So when we are talking about Thailand, we are very well known about the agricultural countries, because we have several the varieties of the products. Yeah, that's why we are so much consider and interest about soil and soil informations, which can be applied in the planning. And because of in Thailand we have, if you know, or I don't know how much you know about Thailand, but in Thailand we have four regions covering whole of Thailand. In each region itself also have different terrains, different landform, and different characteristics of the soil. So therefore, soil in Thailand are variety, but I think it's less than in Russia. But I don't know how many soil series in Russia. When I was in Russia, I also visited the museum, Dukashev Museum. You have this lot of the profile and monolith, which is very long, like 20 or something like that, a meter depth, which is very high and so interesting. When we are I also talked to Thai participants that Russia has huge museum, Lukashev Museum, and the huge of the soil profile. Not only that soil profile monolith, yeah, they give the information. They give also how about what is that land cover, or plant species which is growing on the top of that soil, which is give more characteristic of the soil for growing plants. So, and in that case, Thailand is smaller, very smaller than Russia's, of course. So, but still, we have the variety of soils. Recently, we have it's about 400 series. That is the difference. So, not only in Thailand, using the soil information and soil data for agricultural purpose, but we also use it in another purpose like land degradation and a lot of erosions prone areas covering whole of Thailand, especially in the sloping area. And erosions, landslide, and also you may have note about the flood. Big flood in Thailand also happened in Thailand as well. All of these need the soil information is needed. And another purpose like engineering infrastructures, also making a use of the soil data and information. Like if you would like to build or construct a road or building, you have to consider about soil information and soil properties, which is can be applied and make a plan for your that's proposed. And about ecology, ecological purpose, because in Thailand we have several areas which is reserved and conserved for kind of the wildlife sanctuaries or other special plants, which is we have to make conservations of it. And also the military purpose, because recently our organizations just being contacted by army people that they would like to make a use of the soil informations for military purpose, like they would like to have the troop movement, and they consider that too in Thailand. Especially that in Thailand we are considering that making a land use planning in watershed. We call it the on-farm watershed management. And there are several activities which is in on-farm and covering and managing in covering area of the watershed. So previously in Thailand, I think not only in Thailand, also in Russia, we have been working and practicing and using that what we call is traditional soil survey and mapping. Here, this is I cannot say that it's old-fashioned, but it's still being used in many countries like us. And traditional soil survey, which is the basic background, is about how to achieve the soil information by making a surveys, the observations from the area. And before that, before we are going to make the observation, we have the process of data preparation. Here I call aerial image interpretation, which is used manually and by handing, using a man. That is more is using the expertise. You have to know. You have to have the expertise in that way of the area photo interpretation. And based on that, you have to have the good background about survey. And there's another step is when you get during the data preparation, the area or image interpretations do we achieve like area image classification. That's by hand, manually. And you get here, for example, in this figure, is giving you about the boundary after you make the interpretations, and then you are going to field, collect data along to the boundaries of the soil map. And then finally, after that, you have to compile all soil data from observation and from laboratories, and make what here is the draft map, and it can be paper and soft copy, not in the digital format. Why I'm talking about digital, the traditional soil survey, because before we are going to talk about digital soil mapping, we have to look back to what we have done, what we have been using before. So here I'm introducing you about what Thailand we have been done. Basically, yeah, it's mainly and at least 4 processes we have to do during the traditional soil survey or conventional soil survey. This must be the same. And then why we need a digital soil mapping? Before we are going to talk about large-scale soil mapping, a digital soil mapping methods can be applied even at a small scale, finer scale, large scale, and it can be very fruitful and very valuable for soil surveyor or soil scientists in the future. But basically, you have to know about what is the digital soil mapping approach. And yeah, of course, for us, it's quite new. I don't know about Russia, but if you may have heard about this before, but maybe any of you and Myanmar also can have use it. We can share in any idea, yeah? So let's say that about 15 or 20 years, it's having the digital soil mapping has been established and applied, especially in the very civilian country like America, Australia, Canada, whatever. But China as well, but China is big, it's huge, but cannot be applied in the whole country. So they apply in some areas, some the importance of well-known watershed. You know how about the advantage of digital soil mapping? They have been using it for updating old soil map, or we call updating the existing soil map. And by upscaling or downscaling, it could be fine. And also another way around, they use for the producing some new soil maps, especially in unmapped area or inaccessible area, especially like in mountainous area, where recently that we consider we need also some information which is need to be mapped. And the applications of this is more advanced, going to be mapped in multi-scale. In multi-scale and for multi-purpose. That's what I have been talking about that. And especially that if you are working with digital soil mapping, you can also assess or validate your soil map quality. Here we talk about because of soil has been formed over the uncertainty. Uncertainties along to the geographic uncertainty. Uncertainty because of the mapping process. Uncertainty because of the established soil properties. So all of this can be validated and assessed. So that is the advantage of digital soil mapping. So now I just motivate you how important, how the advantage, how can be applied for the country, which very much considered about soil data and information, and then yes, we can we can interest, yeah, we can have interest of applying digital soil mapping in your country. So, and you might curious now. Okay, there was the advantage of a digital soil mapping process and method, but how to apply? Here I'd like to present you that, okay, what the examples that you can replace some method and some procedure along to the conventional soil mapping. For example, the first one is about area and image interpretation. And in recently, if any of you have used to work with the area photo interpretation, the guys who's working with this, he used a stereoscoping term to interpret both two photos together for the 3 dimensions, and then achieve the difference of the terrain, and all we call landscape, and then drawing by hand. But recently we can make a use of soil landscape modeling, which is applying the digital elevations modeling, which is more modern and more advanced. And that is the first step. And the second step is about the area or image classifications. Term to draw by hand can be replaced by digital and delineations by computer. You know, all of this can be in digital format. we call the landform class. And there are several techniques. I just give you a brief talk. And then from a field check or validation, there's methods of sampling design. The sampling designs also can be used, the digital story mapping techniques, to select the interest area. For example, in the previous time, you might have the random samplings of observation, which is use a lot of money, and you might have to use in a square kilometer, you need thousands of these. But if you use the sampling designs digitally, you might need like, if you need like 20%, 70% confidence, the number of your samplings must be reduced. But if you need 100 of the confidence, you might need more, like that. So in these steps, we can use the observations, and also we can make a use of existing story maps, which is from the conventional or whatever. And after that, map compilation, the mapping method, we also can replace or can apply it using the digital predictive method, which means it can be used term of normally term to use it in replace of the man expertise. But then we use man expertise and we create it in a computer, and let computer map for you based on your expertise. And then it's more advanced, more high accuracy, and fast and cheap. So there's the advantage of digital story mappings around the world they are using now. So, and then the last one, what I have told you already about uncertainty in validation. Because of recently, everybody said, okay, from the previous methods, we have their standard. During the standards can be in any process, like main 4 processes here, we have standard. But all standards can control by itself. But some, nobody knows how much you can believe of your map. And then digital story mapping can help you for how much, like 60%, 70% of the area you can believe it, and it convinces to you user. That's why I'm talking about digital story mapping. But I'm not saying that conventional story mapping is not good, it's good, but we are more advanced. We are more in the technology era. We are more in terms of the modernized era. So term to apply, not all replacing, but apply based on same background. About story size, still same. You have to know the redox depletions, you have to know the redox isomorphic feature, you have to, everything's the same. But it's just the method can be helpful and using and making help you to produce high qualities of story map, and can be easily updated like that, yeah. Okay, the 4 process here, I make it fastly, talking about what is the result you can achieve from. The first step, you have the data acquisitions. All of this can be from digital format. And then after that, you can achieve another format of the terrains, like terrain modeling. You can, previously we know about mountain, Piedmont, but recently when we are applying to use digital story mapping, you can use the digital elevations modeling, which is again give you more about the more and complex of the terrains, and by yourself visually, yeah, by eyes. Sometimes you cannot say that here is a convex shape, the concave shape, or how about the aspect of the slope. But digitally, when you are using and working with computer, this can help you. And you also can note about how's about the Westnet's index in each. That is the index that you can, preferably that you can apply to achieve the source moisture. And after that, you can have the data processing analysis using computer, which is computer can be very straightforward and straightforward talking with you, and not like using man bias. Yeah, you know that how much bias we have when we are mapping and we are talking about, sorry, because it's based on man soil survey expertise. And finally, there is a digital soil map. Yes, recently we have a digital format, but it's not from digital soil map procedure or method. So, then, okay, when talk about digital soil mapping, and you may say that how much money you have to use for applying digital soil mapping, and how much you can believe, and what is the advantage. Briefly, when you are going to apply or present or defense to your government's term to give you budget, to release budget, just tell them that digital soil mapping can help for everything's in the digital soil mapping term to reduce the cost of producing soil map, because in the previous time we might use a years to finish soil map, but recently we just use 1 to 3 years. It depends 1 to 3 months. It depends on the scale. Yeah, if you need a large scale, of course, it might take time because you need more number of the soil observation. But you need the semi reconnaissance, the semi detailed photo soil map. It may reduce a lot of times for you. A month or 2 months, it can be finished. And then tell them that we have more accurate and very precise of the soil maps and soil data information. Of course, time reducing. So when you reduce time, money also can be reduced. And also reduce field work. Because in Thailand, recently we have problems about human resources. I think in many countries, what I have been giving the presentations around the world about digital soil mapping, we are facing the same problem. Is about number of the soil surveyors reduced because of the salary and everything, but they ensure that okay, soil survey they might have new techniques to be helpful. That's why they reduce it. The number of soil surveyor is costing some money, so field work reducing. Here, like in Thailand, previous times we have more than is about 100 of soil survey staff working in the field. But you know that recently, the main and the process can be achieved from 13 staff of soil surveyor, and half of that they are young. Yeah, that is we are. So when we are working in the field, plus of the budget cut problems, we cannot like working a year in the field, but we have to be working in the field half of this and then come back to the office and be working in office again. So term of this, digital soil mapping can help you to reduce the number of the survey, but give you more high accuracy of the soil map and easier for documenting because of since it is already done by digital format, and then you can any of the user can ask you about the soil information, and it can be achieved and extract easily using the computer. Yeah. You see how different about the result of the soil map from the conventional soil mapping and digital soil mapping. Or this can be achieved. So I'm going to talk about the advances of digital soil mapping techniques and more advantages. What are they? Because you might think, okay, you are talking about the digital soil mapping and just give me an example of what I applied or another people around the world can be applied. Yes, what are they? Like when I'm talking about about digital soil mapping recently, I will focus about predictive method. That is also another part of digital soil mapping techniques. For example, the very famous and very favorite methods have been applied around the world, like first logic, because first logic itself can tell you about how uncertain of the soils and how uncertain of the area and men, and how uncertain of the data, and then it gives you a lot of convincing the promisings, like artificial neural network also can be helpful for you to simulate about your neural network, and then put the computer can be working for you. That's why they call artificial neural network. And another modeling like geostatistics modeling also applies a lot in around the world and very productively and successfully. This is the constructions, and just briefly talk, and how to cooperate with this. And the first one, when we have the data acquisitions, and then we have data, the procedure, and all of this can be working in the computer. And then modeling and like physiologic artificial neural network or geostatistic modeling can be applied in the process of data processing. And then data processing. And then finally we can achieve the result of digital soil map. For my presentation today, I'm going to talk about focusing you more about the predictive method in digital soil mapping approach. So you know that how the coverage to these methods for soil mapping. Digital soil mappings require you can use various data. For example, you can use the climate data, you can use the land use data, and just, put everything in computer, and then you can play with the modeling, and then you can achieve finally the soil properties and the soil types or soil series maps based on your observations or the sample data. So when many of soil surveyors might have arguments with me that when you are talking about digital soil mapping, you forget everything's background of soil size. No, it is. There are Gini equations and Gini equations talking about the soil is from the functions of climate, organism, relief, parameter, and times. And recently, when we are talking about digital soil mapping, and Mac Bradney, the guys from Sydney, who developed and modified again Gini equations to Scopan method. The Scopan method work also with the spatial positions we call in. The spatial positions, which means you have X and Y, and you have the positions very exactly what the soils had been formed. And then referencing and explaining in detail of the soils over the background and basic backgrounds of the soil forming factor and plot positions has been formed over the area. So in Thailand recently, what we are trying to test, because when we have the factor, 5 forming factors of the soils in Thailand, we are trying to test and considering very much about the subparent materials, or we call lithology here, and storage. With the storage, there are two of the soil factors, forming factors, very much talking in the worst stage, because it's very important about to study about soil genesis over the landscape, and how much the degree of soils developed over the area. So in Thailand, when we are talking about soil material and storage in Thailand, we are trying to make a use of the remotely sensitive data, what we call is Imagery. The Imagery imagery, because the Imagery in Thailand is more advanced for us, in Thailand. Maybe in Myanmar and Russia, you might have a lot of information. Like my friends from Russia, Moscow, he also use another material. But in Thailand, we are get very fit from the Imagery imagery. But it's a Scott scale. The resolution is about 400 meter by 400 meter. You know that the Imagery what the Imagery can tell you is about the potassium, thorium, and uranium equivalent and the concentration. And especially that it gives you the information in half meter of the soil, like 45 centimeter and 250 centimeter of the top of soil, it gives you about that information. But in this term, you have to interpret, and you have to learn to know how much the camera can tell you about the soil based on potassium, thorium, and uranium's equivalent. Yeah, there are the example of the layers. 3 layers are percents of potassiums and equivalent thoriums in ppm and equivalent uranium in ppm as well. So 3 signals can be achieved from gamma ray imagery, but is now this data has coverings, is already produced covering whole of Thailand, but in each area has different details. And more advantage of Airborne gamma ray for soil survey, we also can apply it in the 3 dimensions. When we are working with the digital soil mapping, it cannot be only one layer that we can play with, but several layers like dam or hills can be helpful for you to understand about 3 dimensions. If you remember from my former slide, I was talking about the 3 dimension, which is the guy who been using about stereoscopy, and then they try to interpret term of the 3 dimension. But here we can use a computer. We don't need to use equipment like stereoscopy. Using the gamma ray itself and the dam and digital elevation modeling can give you idea of the 3 dimensions of the area and how much the concentrations of the uranium, potassiums, and thoriums be found in the area. And then you can study about the soils, which is from 3 components. Yeah. So for the 3 elements of this, it gives you a lot of the properties that you can interpret. Of course, but not by your expertise and also from your computer. Like you can use the classification by using the clustering. Physically means clustering, maximum likelihood clusterings to cluster to make the class of the area. And then you can study about soil geochemistry and materials over the area. And moreover, in this stage, you can study about the weathering index of the soil. And then you can explain in terms of the pedogenesis process. From the process of using this, you can answer like, what's the extent of the Airborne gamma ray explained you about the soil patterns, about parameter and degree of the weatherings, and the times index of developing soil, and about how much gamma ray can be helpful for you to delineate the soil boundary for you, and in what scale. So I would like here to give you examples about the study area that we have been trying to apply it and successfully done. In this area, consists of 5-6 mains of the landscape. That's why we selected this area for the pilot area to study. It has several things, but many of the soil existing data can be useful for to apply in the digital soil mapping method. Geologically mapped units, soil series, landscape, and Airborne gamma ray, whatever. Not only one of these. This is just give you the idea of how different and how about the differentiations about the landscape in the area. We have high mountainous area, hilllands, valley, we have Piedmont, and we have valleys. So that's why this area is very suitable for studying and in applying digital soil mapping and methods of applying the gamma ray. So here. And we also use the existing soil map from Thailand, which is a scale, with the scale is 1 to 50,000 scale. And what you have seen here is the name of the soil series covering the area. We use it to study with the comparisons of applying the gamma ray later. And there are also using the geological map also being used, but the scale is very cost. there is a, you see how much of the difference about the terrains, and the difference also can be from the geological unit. But you know, in one of the geological unit in Thailand is maybe implied several of the rocks type. In one unit can give you several of the paramaterial subsoils. So that's why I applied here to use gamma ray, because you might have one period of Jurassic, something like that. But there are several compositions of the rock. Then the gamma ray can be helpful in this term. And when we are using the airborne gamma ray imagery, yeah, there are this is just how to produce. I will fastly pass this step. And then what is the detail of the gamma ray can give you is about spectrum, because in each of the image give you the spectrums of the airborne gamma ray, and then give you also the criteria of bedrock and times for the weathering. And there also the compositions and the components of in each of the rock types, like intrusives, how much intrusives of granite can give you how much of the compositions of the potassium, uranium, and thoriums in each of the soil. Yes, the first one is about intrusives, igneous rocks. Here is extrusive rock and also sedimentary rocks. It's give in different detail of the compositions of the mineralogy. So the method of this, I used the gamma ray, made the interpretations by using the clustering, and then using also its interpret term of the 3 dimensions, and making a fusions of the performs. I use hue shade, and from the hue shade itself, I have special techniques of combining with 3 angles and time and directions of the hue shade. So in this area, from the 2 dimensions of gamma ray here, finally I got the 3 dimensions of the airborne gamma ray imagery. The black lines here, considering about the flight line. From the flight line from the aircraft flying, we get the flight line. And then after that we have the methods to interpret or extrapolate from the lines to map, covering the whole area, entire area. And we call gamma ray imagery. And after that I use the clustering gamma ray data. This is just method. I'll give you information later about this. And after that, I use the covariable like geological units, petrological units, which is considering about landscape and landform. And I use the soil series, existing soil series maps from LDD ourselves, term 2 map, sorry. And the last one, I make the relationship between gamma ray data and geological units, how the gamma ray is relating to the soil geological unit. And rocks and soil sampling can be classified and then were compared with the gamma rays to a typical radio elements response in the literatures. And after that, the third stage is about data analysis to interpret the gamma ray, airborne gamma ray data about paramaterials and the soil genesis, or we call times factor. Yeah. And finally, we make map by clustering using physics-chemistry. So from the results, I can briefly talk that because time is very consuming. I can briefly talk about if you apply this, you know that's how much the base corresponds of the soil and gamma ray give you very high correlationship between gamma ray and soil. And many of soil series can give you a very rich correlations, but some always field give you poor correlations. Because we have to be frank, nothing perfect, no one perfect. You have the advantage, you have disadvantage, but you have to know how much the advantage you have and how much disadvantage, and then you can solve it. So I know that we know that the rich correlation and what is a poor correlation and why. And then we can use another factor, because we cannot use only one can give. It's not a god. Gamma ray is not a god. It cannot give you all things, but you have to consider that it's just materials can be helpful, or it's just a tool. And all of the soil types here, considering to the soil series based on gamma ray, can be applied in clustering and give you very successfully mapped and very good result. The relationship between soil and gamma rays it can be helpful for you very much to talk about, to differentiate about the rock types. This that result based on the box plot, and also it also can give you the data how much different. And then when you use the the data for spatial analysis, we call geostatistics analysis, it can give you also how to differentiate and how much the upside data. And when you know about this, you can easily and then perfectly apply it. When the results talking about the relationship between gamma ray data and geological unit, it gives you a lot about how to differentiate rock types in each of the geological unit, like a PTRV. In PTRV, Permian Triassic volcanic rocks. In this one unit, you can have sedimentary rocks, metamorphic rock, and you can have igneous rocks. So in one unit, nobody knows how to differentiate it, but a gamma ray can help you. This is just example, but here I already report that how to make use of gamma ray to differentiate kind of rocks types in the area, especially in one unit of the geological unit. All this, what I have done is not only using the single elements. I also been used two elements together. For example, for the green ones here in the figure D, there is I can use the equivalence of thorium divided by potassium, and you get another differentiations of the rock. And in D, you can use the equivalent uraniums divided by thoriums, and then you get another compositions of the mineral. You see, all of this can be helpful, not only the single elements, but in the two elements, but in terms of playing with the computers digitally, you can apply many more. So there is a result of this. What I can say is that I will leave you more about the discussion. That I give you more. Here is the result. Give you what the high and very perfect number of the relationship between the gamma ray and the soil over the bedrock materials. From the bedrock materials, we have several very successful result. Yeah, like this. There is a concentration. Yeah. You see, not only in the bedrock area, or we call residual material, but also in the alluvium materials, it also can be applied. For example, you see the last fourth of the profile here give you the recent alluvium, and also mixed materials from old alluvium. It also give very good result about the mineral components from airborne gamma ray soils and rocks. And there is the locations of the study points. And there are the descriptions and details about how relation between rocks and in each area, and covering into the bedrocks areas and also the alluvium materials. You see, from the recent alluviums also can be applied in very high percentage of the confidence. Oh, sorry. The recent alluvium, and here is all alluvium. Also can give, like here, we report about in all alluviums materials, alluvium materials, it gives you very relatively low K percentage and high of the thoriums and moderately giving you in uranium contents. That is because of it gives you different compositions of material in the rocks, like potassium. Thorium is in alluvium is give you the signal of fragment. In fragments, fragments in that area is very high of silica. High silicas show you in the high thorium. It might be confused sometimes, but we can talk in detail, yeah? So, and not only already test it in rocks and soil, but I use also to test with the soil series. How the gamma ray can be used to differentiate about soil series, you see? And there are several of the soil series in Thailand can be differentiated using the gamma ray itself, like BO, we call Bortai series, which is the classification is about cause loamy kaolitic typic ultrastox, which is give you high contents of the thoriums, low contents of the potassium and uranium because of the sandstones, and this soil has been formed over the sandstone. That's why I remark here is high thorium's content is reflected to kaolinite and sandstone here. Okay, for the next slide, and showing about differentiations about source and signals of the gamma ray imagery. But remark here, I used 3 bands, yeah, 3 components of the. Not 2 components. I used thorium, uranium, and potassium together, make the ternary map. The ternary map is the 3 components of the elements: thorium, potassium, uranium. Try to explain about soil has been formed over the landscape and making a use of the gamma ray. You see in the black circle in unit. Even in Thailand, more advanced, yeah. And if you have seen the SC units, SC is the slope complex, which is is not yet defined. But when you are working with the gamma ray, it can be very useful later in terms of to explaining about how much the soil can be mapped over the slope complex using the gamma ray, based on what I can easily say that based on the difference of the color. But deeply, when we are talking about the signal or reflectance of the 3 components, potassium, uranium, and thorium, it gives you more difference. So in Thailand, is can use and making a use and more advanced on this. So I show here is about the base correspondence, like in Bortai series, Taiyang series, and Chaibaran series, and they give you more remark about how about the high correspondence, and there is the reasons giving you here. Still, yeah, the base correspondence still going on here in many series. But what I have seen is base correspondence, yes, but we have found that some of the area that we cannot is very poor, give very poor correlation. Because there are another factor, not only paramaterials, which is gamma ray cannot be explained by this moment. Yeah, maybe in the future, if I can deeply more study about this, I can explain by using this. But in the moment, I say okay, poor correlations, go to the LA series, which is we call Lampura series, which is, has been formed over the flat area. What I can give you here is about the broadly defined about that soil series, or is about the reflectance interfere or influenced by another factor, like we call not uranium abundance, we call cobalt abundance, which is really effects to it. But in the future, if I might I'm going to try is how to solve this problem. Here, the mismap of the LK series is mostly defined in the Piedmont, but is sometimes is happened in some areas in the residual materials. That there are just example of the poor correlation, but what I have seen is that the best correlations, risk correspondence is higher than the poor correlations. But still, we have to study about the poor correlations term to resolve it later. Here is about the signal of potassiums and unit. This can be found in in SO or TL soil series. Because of two of these are almost familiar each other, because of the parent materials, mostly the same, but only the properties is different. Like SO series is term of the very shallow soils to lithic context of the igneous rocks, but TL series is the shallow soils, but the deep is confined by the gravel of igneous rocks. So, but it's the estimates of two series is mostly the same, but only the context layer are different. Here I said the detail of delineations in quaternary periods is give the bright here is give you more confusions, yeah, but we have to go more deeply talking about that. Finally, when I'm talking about to study the gamma ray for differentiations about soil parent materials and age or times of the soil, and finally I'm making a use of the gamma ray with the digital elevations modeling DEM, yeah, to map soils, to apply the fuzzy means method to map soil in the area. And after you let the computer do it, the fuzzy means you can search it from computer how it works. Yeah, but because of fuzzy means give you uncertain and not yes or no results, but it sometimes give you the probability of the soils can be found like a 60 or 70%, but it depends on how much you can clarify and define how much percentage of the probability of the occurrence, and then you can generate soil map easily in one day. And this is just procedure. So finally, I get the results of all of the soils, but I give the symbol here is S127. It's stand for they are stand for the residual soils. A1, A2 is are stand for soil over the alluvium, which is all alluvium and recent alluviums together. So in the conclusions of my study, of our study is about we can make a use of gamma ray and digital elevations modeling under the digital soil mapping process to refine the existing soil map, refine the boundary, refinements of the delineations of the boundary, both in quaternary alluviums and especially in gentry undulating and undulating, as also in hilly areas or mountainous areas. Another conclusion is about paramaterial differentiations. In Thailand, we have a lot of problems when we define the paramaterials, but yes, right now we can make a use of the Airborne gamma ray. And for the recommendations of applying in Thailand, and then maybe considering to be another method, showing and motivating you in terms of applying your area, your countries, is that digital soil mapping plus the remote sensing data, but you have to select a suitable one term to improve the existing soil maps, especially for non-agricultural purpose and agricultural purpose together. And especially in Thailand or in your country, I think if you have mineralogy department, you might have the Airborne gamma ray. It can be helpful for you to pre-map the stage of the lithological mapping and knowing about the stage of the soil development and the possibility of knowing about the topsoil's properties. This in Thailand we call phase of soil series. And to improve the quality of traditional or conventional soil maps that is also can be applied. Based on this, here is the citations of this paper, which is already published in the Geoderma journal, and then you can find it from there. Okay, thank you very much for your attentions, and anybody has questions and recommendation for me, please feel free to explain and then share it together. Thank you very much.